Welcome back, ladies and gentlemen. Um, the session 2 of this seminar is on the economics of green hydrogen in Indian perspective. It's an honor to have our DG, Dr. Ajay Mathur, as the chair of the session and help us do the moderation. Dr. Mathur leads a 119-member intergovernmental organization promoting solar energy adoption. Under his guidance, the ISA initiated solar projects and capacity building in developing nations. Notably, the ISA is establishing a solar facility to mitigate investment risks in African countries and launched a program supporting solar startups in the continent. The expert speakers of this session are Dr. Ashish Lele, Director, National Chemical Laboratory, Pune; Dr. Pradeep Tharakan, Director, Energy Transition, Asian Development Bank; Mr. Shreyans Jain, Investment Officer, Upstream Asia Manufacturing, Agribusiness and Services, IFC; Mr. Sturle Harald Pedersen, Chairman of the Board, Greenstat, Norway, and he also happens to be a member of our GHIC Steering Committee; Mr. Mathieu Geze, Director Asia, HDF Energy. He's a member of our GHIC Steering Committee as well. Ladies and gentlemen, we'll have initial 7 to 8 minutes of talk by each speaker, followed by discussions. Over to you, sir, Dr. Mathur.
Thank you. Mridula has told me that I need to keep on time. We cannot afford to be late anymore. So without further ado, we are looking at 5 speakers and then an audience interaction. So we are looking at 8 minutes per person. And what I will do is when it is nearly 8 minutes, say 7.5 minutes, I'll start waving my hands so that people know that we are getting to time. I'm delighted that we have Dr. Ashish Lele, Dr. Pradeep Tharakan, Mr. Shreyans Jain, Sturle Pedersen, and Mathieu Geze here with us. They together have focused a lot on making hydrogen, both its production and more importantly, its utilization cost effective. We look forward to hear from them because ultimately what is important is that the user sector will start adopting hydrogen appliances and products only if they are cost effective. You may have 1 or 2 people who may do it for reasons of international trade, for positioning themselves in this area and so on. But large scale movement will occur only if it is cost effective. And therefore, the economics of green hydrogen becomes an amazingly important issue. And to start this off, I am requesting Dr. Ashish Lele to start off and request him to share his thoughts with us. And as I said, around 7 minutes to 7.5 minutes later, I'll start making all kinds of actions to draw your attention to the fact that it's getting close to 8 minutes. Ashish.
So I want to touch upon the utilization part of the hydrogen because clearly, if you do not have an off-taker who's willing to take hydrogen at a price that you want to sell it, the hydrogen economy wouldn't kick off. So, therefore, starting off with that today, if you look at the cost of production of green hydrogen by electrolysis, at today's capex and the renewable energy prices, with all the incentives that are allowed by both central and state governments in India, somewhere around $4 to $5 per kg is what it turns out to be the cost of producing green hydrogen by water electrolysis, and that's still at least 2x more than the gray hydrogen price as of today. So we think that, of course, this has to come down, and with the improved tech of electrolysis, most importantly, the lower cost of capital to whatever different options that we have, use of both hybrid renewable electricity and use of curtailment, and in particular, with focus on having integrated renewable energy utility plants integrated with electrolysis, If all of these factors come in, I think there are many reports, and our own calculations would suggest that the cost of producing hydrogen can come down to as low as $2.50 per kg. With integrated plants, it can come to even slightly lower than $2.50 a kg. And that is still a little higher than the gray hydrogen prices. So, if one can think of allowing the use of relatively low carbon intensity hydrogen. When I say relatively, it's relative to gray hydrogen today. Then the cost will further come down. And I'm looking at technologies like, small compact reformers which are electrically powered, whose carbon intensity today is half that of today's reformers. So if these kinds of lower intensity, not necessarily what we call green, but lower intensity hydrogen is allowed in the markets today, then the cost will come down to what is gray hydrogen cost, and therefore that will in a way kickstart the utilization of hydrogen in many sectors. India also has the possibility of biomass to hydrogen. There are a lot of debate around what is really the carbon intensity of hydrogen coming from biomass. But if one were to allow this hydrogen to be called green, assuming that the carbon is a bio-based carbon, then clearly the cost of producing this hydrogen is very competitive to today's gray hydrogen. There are also other production techniques which are low carbon intensity hydrogen, such as where hydrogen comes out as a byproduct, keeping in mind that the main product that comes out has an inherent value. And there are a few examples of these. For instance, the pyrolysis of natural gas, or even better, pyrolysis of biogas is one such example where hydrogen comes out as a byproduct. And if the carbon produced in the process can be valorized, if it has the right morphology and the right purity, then this hydrogen, which is a byproduct and has low carbon intensity, is also an extremely attractive position. So any which way, if the cost of producing hydrogen comes closer and closer to today's gray hydrogen cost, it is the key point in kickstarting the hydrogen economy across India. And the first targets there then would be the relatively lesser hard to abate sectors. And of course, there is much talk on refining, and that is driven by the assumption that the price that one pays, a slightly premium price that one pays for green hydrogen, would have a lower impact relatively on the GRM, the gross refinery margins. However, that needs to be worked out, and as of today, this has not happened. Not. I don't know any of the refining sector in India has really started injecting seriously large amounts of green hydrogen versus gray hydrogen. However, this hydrogen would still be okay for exports, and I'll touch upon exports a little later. So there is a lot of refining, but it's to be seen how much impact of green hydrogen at a little premium price will have on the GRM, and how much the refining industry is willing to adopt it. There is, however, one sector which I want to particularly attract the attention of the audience to, which is a key strategic sector for India. And this sector is the fine and specialty chemical sector. As you will know, India has a pole position in this area. These I'm talking about pharmaceuticals, agrochemicals, dye stuff, colors, pigments, fragrances, flavors, construction chemicals, and a whole host of these fine and specialty chemicals. And today, hydrogen is used in this sector very widely as a hydrogenating agent. Hydrogenation is a platform technology across the fine and specialty chemical sector. My own guess estimate is about 200 kilotons per annum, perhaps even 250 kilotons per annum is the consumption of gray hydrogen today in this sector. All of that hydrogen, well, most of it is purchased through merchant sale. The price that these industries are paying today for this gray hydrogen is, as of today, at least 400 to 450 rupees per kg, and that's already about $3 to $4 per kg. So we're talking of gray hydrogen, and you're still paying the price that green hydrogen is available at. And this sector is therefore a very attractive sector for replacing gray hydrogen with green. It is even more attractive because much of the chemicals that are produced today by this sector are actually export oriented. And therefore, this industrial sector is already facing decarbonization pressures in markets outside India. And therefore, they are more than happy to pay the price of green hydrogen, which is anyway not so far away from the price they are paying today for gray hydrogen. And so I think India should look at uh, these kinds of areas where these are low-hanging fruits, in my opinion, where substitution of gray hydrogen with green hydrogen is entirely possible. I think there's a lot of talk also on iron and steel, and it's very heartening to see that our own industry is already doing several experiments on injecting hydrogen to whatever extent in blast furnaces. But this is not easy. These are really hard to abate sectors, and this is likely to happen a little ahead in the future. Midterm, we believe that shipping, inland waterways, and heavy commercial vehicles on the road will likely adopt hydrogen. We ourselves in our lab are very happy to have collaborated with industry to have launched India's first hydrogen fuel cell powered catamaran. This recently happened in the Cochin shipyard. We're happy to have our fuel cell powering this vessel. And I think we hope that as the
Ashish, in case you can't see me, I'm flapping like a chicken because the 7 or 8 minutes are over.
I'm done. So just one last sentence that if we couple the heavy transport vehicles, transportation of freight with the national logistic policies, and given the large infrastructure buildup happening on the Bharatmala scheme in India, as well as the Sagarmala scheme, I think in my opinion, we will look at use of green hydrogen in the transportation sector, whether it is waterways or roadways. So I'll stop there, Dr. Mathur, and maybe more later as we continue this discussion. Thank you.
Ashish, many thanks. There's one very specific question that I had with respect to your talk. And that is, how do you think that in the future, the scaling approach, whether in terms of the size of electrolyzers or in terms of the numbers of electrolyzers, that alone can help in making green hydrogen economically competitive?
To some extent, yes, because as we all know, the largest contributor to the levelized cost of hydrogen production is the renewable electricity price. So that's about, at a scale, about 65 to 70% of the LCOH is contributed from RE prices. So to the remaining extent, indeed, yes, as the scaling up happens, the economies of scale will kick in. The capex will come down. We are hoping that we will look at capex of electrolyzers to what is today available apparently in China, about $250 to $300 per kilowatt. If we come to that using the scale, then there will be some positive influence on the LCOH coming down. But definitely the cost of renewable electricity is the key price, is the key component.
Ashish, it actually flows into the next session, next presentation itself, but I can't help but asking if the cost of electricity is the single largest cost, and if green electricity is supposed to meet, by definition, green hydrogen is what comes from green electricity, what are the price ranges that we are talking about in terms of cost competitiveness of green hydrogen?
I think we are all looking to 3.5 rupees a unit as the desired price of electricity. With all the incentives, both state and central, I think we are looking today at about 4.2, 4.3 rupees a unit. If that can come down to 3 rupees a unit, then I think we are looking seriously at an attractive green hydrogen price. So there's still a gap from 4.5 to 3,
Right.
in my opinion.
No, thank you very much, because tender which was opened, I think last month or the month before that, by the Railway Energy Management Company had 24-hour supply of electricity, green electricity at between 4 and 4.4 rupees a kilowatt hour. This was wind plus solar plus storage. And this is not amazingly far. It's far, but not amazingly far from the 3.5 number that you talked about. So thank you very much, Ashish. Uh, 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 I know that you're traveling, but I would request you to stay on. And meanwhile, I know that Shreyans has to leave early. So Shreyans, can I request you to speak for the next 7 minutes or so?
Sure. Thanks, Mr. Mathur, and thanks for accommodating my request. So, thanks, Ashish. Thanks for all the insights. Maybe what I would like to do is that provide some insights based on a financier's perspective in terms of what we are seeing in the market. As Ashish said, as today the price of green hydrogen is 2 to 5 times that of gray hydrogen. Now that totally depends on the industry that you're looking at. And I would probably like to make the statement that we are already seeing that in certain industries, green hydrogen has become cost competitive to gray hydrogen. Now, I think Ashish touched upon the steel sector, and what we are seeing here is green hydrogen has the unique ability to provide a fixed cost or a visibility to the off-taker in terms of what the cost would be, whereas currently gray hydrogen does not have the ability to do that. And that's primarily because the gray hydrogen that is being sourced is totally dependent on the price of LNG. And as we know, India is a net importer of LNG. So from that perspective, I think there are certain industries where we are seeing uh, green hydrogen is already competitive, and that's quite heartening to see. Uh, the other point that I would like to make is, so what is the cost component? So as Ashish said, 60% of the levelized cost of hydrogen is actually green electricity, and 40% is the cost of electrolyzer. Given that we are able to scale up electrolyzer technology, and given that we are able to deploy at scale, I think we have the potential to reduce the cost of green hydrogen significantly. But another insight that I just want to present here is that we are already seeing a lot of innovations. So for example, at this point in time, a lot of electrolyzers are actually imported, whether it be PEM electrolyzers or alkaline electrolyzers, and they are being imported from Europe or they're being imported from China. However, what we are seeing is that it totally depends on what you call the electrolyzer. Is it only the stack, or is it also, the rectifier and other additional ancillaries to the electrolyzer? And what we are seeing is that some of those ancillaries are actually getting produced in India now, and that has had a significant what I would say impact on the cost of the capex that we are incurring. Then in terms of financing perspectives, what we are trying to see is that which are the sectors that will be first off-takers of green hydrogen. Definitely the refining sector would be one of the biggest off-takers. Fertilizer sector, yes, but there are certain challenges in terms of technologies. But what I would like to focus on is the smaller captive green hydrogen plants that we can develop for the CNI sector. I think that is something that we're not focusing enough on, and that has the potential to take off today. We've met quite a few entrepreneurs who are looking to develop supply green hydrogen production centers for the supply to industrial clusters. And some of these customers are ready to sign 20-year offtake agreements, which is again very, very heartening to see. And obviously the economics behind it is that you're able to lock in the price of hydrogen today rather than being dependent on the variable cost that gray hydrogen would present. Then maybe the third aspect that I could touch upon is, what are the key risks that we are seeing as far as financing large-scale hydrogen projects is concerned. So I think while financing hydrogen is new, but it's not something that we are building from ground up. I think if you look at LNG, the way those projects are structured, that they actually provide a blueprint in terms of how big hydrogen projects can be financed today. But the first risk that we are cognizant of is the project on project risk. Now, you see, when you're developing a green hydrogen project, you have multiple sub projects within that. There is the renewable energy project, there is the electrolyzer, there is the transportation infrastructure, and so on. So what's happening is that uh, while, I mean, if you're taking a bet on the green hydrogen piece, and you're not able to develop the electrolyzer, sorry, the renewable energy piece at the same time, that is, where a project on project risk is being introduced, and that is what is not being priced correctly, and that is also leading to a higher cost of hydrogen. So what we are preferring is that if we could develop integrated green hydrogen projects, or at least have all parties as consortium members, so basically the renewable energy developer, the green hydrogen producer, as well as the transporter in the same project, that helps really taking a good view in terms of the risks that are involved. And I think the second most important risk that is being priced in is obviously the offtake risk, right? So ideally, what you should, I mean, while you can probably have offtake agreements with AAA rated offtakers, what really helps is that if the offtaker is a part of the consortium. What also helps is that if there are some kind of backstop guarantees in terms of the offtake, and there is a 20 to 30-year long-term offtake that can be provided, which gives the financier a lot of comfort in terms of what is the risk that is being taken on. I mean, there is a challenge, inherent challenge to that, in the sense that if you sign a 20-year offtake agreement, there is a disadvantage to the offtaker, because what we are expecting is that the green hydrogen price would decline significantly. So you're, locking in a higher price today. The other point that I think is also important is in terms of the pricing. What is the kind of pricing that we are getting from the market? So what we are seeing today is that there is a fixed price, which is basically where you lock in the cost plus element, and cost essentially is the renewable energy. So basically the pricing is depending on the renewable energy. And there are significant price openers in terms of, if there is a significant decline in the cost of renewable energy, that benefit can be passed on to the offtaker. So I think that's also, one of the significant risks that we are looking at. And then maybe lastly, what we're seeing is, and this is based on evaluation of green hydrogen projects worldwide. What we are trying to also assess is what are the kind of regulatory risks that green hydrogen presents in each country. And it is also very heartening to see that as far as India is concerned, I think there is a significant push to support green hydrogen. We've seen PLIs, we've seen the site program, which gives a lot of comfort to a financier that yes, there is significant support from the government on this. What is also helping the cause is that the interstate transmission charges have been waived, so that means that you can actually set up electrolyzer at a place where it is easy to transport to your offtaker, and you can have renewable energy at a place where it is the most cost effective to produce. So that's again something that is being enabled by the government of India. So I think that's something that's really encouraging as far as the Indian context is concerned. Maybe I'll pause here and be open to any questions that you may have.
Thank you. Thank you very much, Shreyans. I am going to ask you a question. Mr. Patil here, or the person who's sitting next to you, Mr. Kamlesh Gupta, they're both from L&T, who are getting into or are actually into the business of producing electrolyzers in India. Would you give them a loan?
Well, I would say that we've been interacting with L&T for quite some time.
Okay.
Right. And I would say that is the key focus, right? I mean, if you're able to support electrolyzer manufacturing in India, I think that's where we can make a difference. You see, supporting a green hydrogen projects will come in second, but what we need to do is support electrolyzer manufacturing. And as IFC, what we've been doing is we've been providing all kinds of support. So 2 years back, I think the key challenge was what is the technology that you really bring in as far as manufacturing is concerned. And there was a lot of debate whether it should be PEM, whether it should be electrolyzers, alkaline, and there is some technology that is coming from China, etc. So we did step in at that point in time in terms of trying to understand, what are the kind of technologies that are most favorable for Indian conditions. And as far as electrolyzer manufacturing is concerned, I think that's from an IFC perspective, that's a key focus for us. And I actually belong to this department called the Manufacturing, Agribusiness and Services. So you would imagine that manufacturing of electrolyzers is definitely something that we're looking to.
But then this leads me to the second question, which related to your request that government should think, or the consortia should think in terms of guarantees for offtake. We see two sectors here, wind and solar.
Right.
Wind developed without guarantees. And so what developed was that the manufacturer of wind turbines also became the person who set up the farm and managed it. In solar, the solar manufacturers and the solar developers were very separate because you had a guarantee with the Solar Energy Corporation of India. Where do you think the hydrogen sector will move?
I think what we are seeing at this point in time is everybody who wants to get into green hydrogen is also getting into electrolyzer manufacturing.
Okay.
And I think one of the key reasons is because there were a couple of years back, if you would have gone into the market, everybody would have said that the availability of electrolyzer is a challenge today. And that is why I think every green hydrogen developer wanted to get into electrolyzer manufacturing. The second aspect to it is that, and I don't know, maybe correct me if I'm wrong, from what I understand in the market, electrolyzer technology is not as complicated as once it was thought of, right? I mean, I understand that electrolyzers have existed forever, and now we are doing a lot of innovation. So to answer your question, yes, what we are seeing currently is that lot of manufacturers of green hydrogen are also setting up electrolyzer manufacturing plants. In terms of our interaction with a few, what they've told us is that primarily because they want to guarantee the availability of electrolyzers and also guarantee the O&M of electrolyzers, because that will be critical going forward. So from that perspective, we are seeing both. I think you also had a question on offtake, right? In terms of why are we looking at signing long-term offtake agreements? I think that is where if you look at the NEOM project, I mean, one of the reasons that financing to such a massive scale project was available is because the offtake was guaranteed by LDK, I think. Yes, it was a long-term offtake that was guaranteed. So what it does is that from a financier's perspective, it can bump off a significant amount of the financing cost, which has a very big impact on the overall project cost. So from that perspective, we feel that a strong offtake is critical.
Okay. Thank you. Thank you very much, Shreyans. We most rudely bypassed Pradeep and took you up first. So Pradeep, can I request you to share your thoughts, and particularly coming from the ADB?
Thank you very much, and thank you for having ADB at this discussion. I think a lot has been said about price trends and sort of the key risks, and I think my colleagues from the IFC also pointed out some of the sort of trends in the market today. So maybe I can just take a step back and firstly briefly introduce ADB as well as a multilateral development bank. So we're owned by 63 countries. India is one of them, and typical of or quite similar to the other MDBs, recently we've all sort of undertaken a mandate to be bigger, bolder, and better. So more financing is available. We're also trying to lower the cost of our financing by blending it with more concessional resources. And we're also being bolder in terms of actually looking at a lot of the new areas that need financing. And so green hydrogen is one of them. I think the previous speakers have sort of alluded to sort of maybe three pathways that we are seeing in terms of hydrogen projects. We've got the really large export projects that are being proposed. There's clearly a price differential. These sponsors think they're able to make hydrogen at about perhaps $3.5 to $4 to $5 a kilo, and there are markets that'll pay upwards of $8 or close to $8. And so there's clearly an arbitrage that can be, tackled. The second is the industrial use, and that's been alluded as well. There are some very interesting models where if you look at the green GH2 steel project, where you've got the off-takers are also part of the project company, so as a way of risk sharing. And so that also gets around the issue of long-term offtake prices. Yes, you are locking in a higher price at this point, but then if you're also in the project company, you get to participate in the upside as well. So that's another model we're seeing. And the third model, I think, which Mr. Lele mentioned earlier, is about really the small scale agriculture waste to hydrogen projects, or the sort of captive generation of hydrogen, which is really important for a development bank. I mean, while we do want to facilitate the larger export oriented projects, because those build scale, they build expertise, they help to bring down the prices. We also, in the near term, do not want to lose sight of those smaller projects, especially in the agriculture to hydrogen space, which will provide a lot more co-benefits as well, be it air quality benefits, better incomes to rural contexts, and so on. So these are all areas that we are pursuing. We are in active discussions with a couple of projects in India. And I think some of the things that we are kind of quite closely tracking is that these are entirely new areas for us. So issues around technology risk has been mentioned. We want to make sure that is fully addressed. And also the utilization of electrolyzers, because that's really what's going to bring down the price and help with more efficient operations. So there was mention of the projects in the Middle East, but they are really going to be relying on solar and with storage of solar during the nighttime, whereas some of the projects in India, which have much better integration with solar, wind, and pumped hydro, would potentially lead to much higher capacity utilization of the electrolyzers, even up to perhaps 75%. So that should really help to bring down prices. And I think the first mover projects are seeking to be fully integrated for reasons that have been discussed earlier, and those are going to be very helpful as well in terms of bringing down the overall costs. I think those are sort of the main points I wanted to mention. And we really hope that along with the development of individual projects, I think we can also help our stakeholders to develop industrial corridors, or what we call sort of hydrogen hubs. And the government has already indicated a few priority states and ports around which these hydrogen hubs are being developed. So ADB is working with the port of Visakhapatnam. We are in discussions in Tamil Nadu, in Maharashtra, and in Gujarat to also help the states with develop roadmaps. So that sort of brings to bear, as MDBs, we've got a lot of expertise in certain areas, such as industrial corridor development of renewable energy projects, which typically have long, PPAs and offtake prices and offtake contracts. We don't have as much experience in manufacturing in things like green hydrogen, which are exposed to market risk. So we want to start from a place where we have comfort, but then move into areas which are newer to us, so that overall we're able to sort of fulfill our mandate. So Ajay, maybe I'll stop here and then happy to take questions.
Pradeep, many thanks. Can you tell a little more about the cluster approach? Because the problem with clusters is, how do you ensure that that there is a user of hydrogen where a producer of hydrogen is set up?
Yeah, I mean, I think it's again going back to this whole industrial areas. I think if you look at a place like Visakhapatnam, where you've got a steel plant, you've got a port that could actually benefit from the greening of its operations. You've got an import export pathway there. You've got access to a large amount of land, which can potentially be the base for renewable energy generation. So it's going to take a fair amount of analysis to identify the major users of green hydrogen or hydrogen to begin with, at the price ranges at which it would make sense for them, the transportation costs, and so on, and then allow for some flexibility and growth as you go forward. But I think that's sort of the approach that one has to take, and this has been done in several other chemical industries. I mean, there's been a history of sort of the hub development, so we'll have to follow the same approach.
Thank you very much. And Stuart, let me move to you and request you to share your thoughts with us. Stuart, all yours.
Yeah, I think he's muted.
Hear me?
Yeah.
Hello? I cannot hear you.
I think you're okay. Can
I'm
you hear
okay
me?
now?
Yes, you are.
Okay, thank you very much. So thank you for the introduction and also the privilege to address this esteemed panel today. India's vision for green hydrogen stands as a sign of optimism in our collective battle against climate change, and it signifies India's steadfast commitment to forging a sustainable and prosperous future. The ambition roadmap that has been referred to earlier today by Mr. Balla for the hydrogen mission, which aims to position India as a global frontrunner in green hydrogen, both in production and utilization and export, suggests a cleaner and more robust energy landscape, not only for India, but for the region. However, as India navigates this transformative terrain, it's imperative to recognize the challenges and also the opportunities that are at hand. And today we have talked about the cost competitiveness of green hydrogen still remains a key factor in its widespread adoption. And we have heard that the production of cost of green hydrogen exceeds both that of gray and blue hydrogen. This is presenting a challenge barrier to market penetration, and to address this cost differential require a comprehensive approach that contains economic considerations and policy interventions. To drive down the cost associated with green hydrogen is imperative to grasp the fundamental economic factors at play. Elements such as energy pricing has been mentioned, and I think that we need to know that 70% of the OPEX is related to the price of renewable energy. Advancement in electrolyzer technology, I think that is also an area which we have not addressed properly, because the technology has been around for 100 years, but there is a lot of room for improvement, particularly on the efficiency, which has been mentioned by Dr. Lele, but also on the durability and the material that we are using for the electrolyzer. There is a tremendous opportunity here to bring down the cost of the electrolyzer, and also on the balance of the plant, which brings me to another area which is important, which is to develop the supply chain, the local supply chain for the balance of the plant for these hydrogen plants. Also, another area which I think that has been under-communicated is the infrastructure development. These all three are exert influence on the overall cost of green hydrogen production. By leveraging these factors and implementing strategy policy instruments, we can cultivate and enabling an environment supportive to cost reduction and market expansion. The government of India has already taken significant strides to bolster the growth of hydrogen, as we have heard today. Through these initiatives, which have been covering renewable energy promotion, research development support, and some financial aids, and to a less degree, infrastructural enhancement, the government of India are laying a solid foundation for thriving green energy economy. But let us not forget that the journey toward achieving our shared objective of net zero emission is a global challenge, which require global solutions and collaboration. Policies such as green procurement and carbon pricing mechanism can play a critical role in incentivizing the adoption of green hydrogen and expedite its cost competitiveness. Rather than reinventing the wheel, concerning green hydrogen policies and crucial economic factors, we can gather invaluable insights from policies of other nations or organizations to detect what strategies prove efficient and what do not. Together, through international cooperation and mutual learning, we can overcome challenges and pave the path toward a sustainable future. Offtake agreements and demand aggregation stands as the critical mechanism for unlocking the untapped potential for green hydrogen. By offering investors confidence and mitigating price uncertainty, offtake agreements can catalyze investment in green hydrogen production. Demand clusters can also cultivate a robust market for green hydrogen, fostering economics of scale and driving down the price for hydrogen. While the road ahead may present a lot of challenges, the potential rewards for embracing green hydrogen are immense. And as we have heard, it's something that we need. And Irena mentioned that 15% of the energy mix in 2050 will be by green hydrogen. If we are working together by addressing the key economic factors and the policy instruments and investment risk, we can unlock India's green hydrogen potential and chart a course toward a sustainable and prosperous future. Greenstat has been developing several pilot projects in India. There are small projects from Torrent Energy. It's a blending pilot where we are blending green hydrogen into the natural gas for distribution to the end consumer. But we are also working in a model where we are bringing both the producer of renewable and also the distributor, which is a special niche gas companies who has a setup of bottling and distribution. This is the only way today to actually make profitable pilot projects, because for all the other ones that we are talking about are not moving forward. And the reason for that is that we don't have an infrastructure in place. So this is one of the most important areas for the government and all the stakeholders to work together to be able to set up an infrastructure with pipelines and also the ports and other infrastructure that needs to be put in place to be able to develop the market and the demand. We cannot produce the hydrogen in a location where there is no offtake because we cannot move it to the market. So the infrastructure will be important, but we cannot wait until the infrastructure are in place. We need to start with a small pilot, and we need to actually convert consumption of gray hydrogen, and the government need to step up to give a timetable and percentage so that the stakeholders and the industry know when they need to put things in place, so we can create an offtake and where we can also bring the risk down on some of these projects. It has been repeated many times today that we cannot find financing, financial closure for many of the projects because there is no offtake. And this is a kind of an evil circle that we need to break. Thank you very much.
Thank you, Sturle. That was very, very useful. And that leads me to the question of what are the specific kinds of economic factors that you think can influence the cost competitiveness of green hydrogen in India?
Well, I think to accelerate the cost reduction, it is essential to focus on several different strategies. First, I think increasing the deployment of renewable energy sources such as solar and wind can and will help to reduce electricity cost. And in this area, I think the government is doing quite a good job. They have already announced that they need 50 gigawatts each year up to 2030 to meet the 500 gigawatt target. So I think in this area that the government are on track. The second one, which I want to emphasize, is that we need to invest more in research and development to improve the electrolysis efficiency and also to reduce the manufacturing cost. This can also lead to more cost-effective production methods. So research and development is an important area, and we need to focus more on this, also to be able to developing the supply chain in India. I think that India has all what they need to actually developing a world-class supply chain for hydrogen, green hydrogen plants. Third, I think it's the infrastructure, the pipeline, and refueling stations. The government needs to step up and help to create a robust market for green hydrogen. And this will be driving also the scale and reducing the distribution cost that we have also been talking about. But the last part is fostering collaboration between the industry stakeholders, academia, and the government agencies. This can facilitate the knowledge sharing and innovation, further driving down the cost and enhancing the competitiveness of green hydrogen in India. So these are the recommendation I would give to the government. Thank you.
Thanks very much, Sturle. I think that was very useful. Obviously, it seems that the government of India is on the right track, but I think reiterating this would be very useful. Mathieu, can I request you to share your thoughts with us?
Yeah, thank you, Dr. Mathur. Thank you for the invitation today. I will start by introducing myself and my background. It will help also to understand from which perspective I'm sharing the views today on green hydrogen. I'm director for Asia at HDF Energy. HDF Energy is a French developer of hydrogen projects. We are very versatile in Europe. We are looking at many types of applications, heavy mobility, power. And in Asia, we are focusing a bit more on power. During my work at HDF, I've met various potential partners, clients related to green hydrogen. And I will use this empiric experience to share my view today. So firstly, I would like to mention that obviously the potential for green hydrogen is there. There is no doubt about it. When we look at refineries, fertilizers, they are heavy existing consumer of green hydrogen. So in terms of market potential, the obvious first step should be to focus on those players because they just need to switch from gray to green hydrogen. We see that the steel industry also will be a heavy consumer of green hydrogen. And I personally believe that it's just a question of time. There is no doubt about the market potential. I believe we all agree on that, but it's important to remind when we talk about prices issues. I do believe it's just a transition we need to go through. The main challenge with those players, and I had a meeting last week again with a fertilizer company in Southeast Asia, is the price. When we discuss what's your current price for the gray hydrogen, usually the answer is 1.5 below $2 per kilo. And then what is your maximum target price for green hydrogen? Unfortunately, the answer is often $2 per kilo. There is the perception that if they go above that level, they will have difficulties to remain profitable and competitive in the market. So at the end of the day, someone should help them to switch to green hydrogen. That's why it takes time to develop projects and to meet gigawatt scale. So my view is that first we need to focus to identify sectors applications where green hydrogen is affordable from today. And you know, the price perception can depend either from a country to another, a sector to another. It's a bit like real estate, whether you are the countryside of Gujarat or downtown of New Delhi, the perception of the price of your house will be different. What is affordable in New Delhi could be seen as crazy expensive in the countryside of Gujarat. I do believe it's the same for green hydrogen. There are niche markets that we can target today and who can be competitive. For example, if we look at heavy mobility for railways application or maritime sector, the green hydrogen can play a role. And even if the green hydrogen is at $5, $6, $7 per kilo, there are many lines in Europe, for example, which are not electrified, train lines. They are not always electrified because of topographic issues, infrastructure development costs. It's expensive to electrify all lines, requirements for new power plants. In such context, the green hydrogen can play a role. It is the case in India, but it is the case also in many countries of Asia. There are many train lines which are not electrified and which won't be electrified. That can be an application. Well, then we have the market for using hydrogen as a storage solution. As working in HDF Energy, I always refer to that because this is one of our core business, is to focus on areas where the cost of electricity is expensive and where green hydrogen can bring a technical added value by storing the intermittent power. If we look at India, there are areas in Ladakh, in Andaman Islands, some areas of grid issues where green hydrogen can play a role and can be affordable. And in such application, there is no debate whether the hydrogen is at $2, $5, or $20 per kilo, because at the end of the day, we don't sell hydrogen, but kilowatt hour. And if the price of kilowatt hour is competitive in such context, it's a way to make a first green hydrogen projects happen. So my first view on the business model to make the green hydrogen projects happen today, not in 10 years, is to look at the niche application where we can make them viable. But then if we can find leverages to reduce the cost and to help the players from petrochemical sectors, chemical sectors to reach the $2-3 per kilo target, why not? And I identified some leverages. So indeed, the scale, if we can increase the demand, if we can reach gigawatt scale, that will reduce the cost. It's obvious. It was mentioned earlier to produce the electrolyzers in India, for example. But that being said, I don't think we can reach the gigawatt scale at once. We need a learning curve. And hence, to have the learning curve, we need to look at projects where it's viable today. So I come back to what I was saying earlier, but that is really important. The learning curve will be key for to reduce the due diligence cost, to reduce the EPC cost. That will be a way for everyone in the market to learn about green hydrogen. And by starting maybe by 10, 20, 50 megawatt electrolyzer projects, it's a way to be more competitive on the gigawatt scale later. Then the development banks, I think IFC, ADB are there today. The development banks, they have a key role to play, a key role to make projects more sustainable during the development. Sometimes some technical assistance are required, not only to reduce the development cost, but to bring some comforts to local stakeholders. Maybe for MNRE, MOP, whatever, the perception on green hydrogen is that it's too innovative, and the support from development institutions can help to address that concern. And then it's obvious during the implementation of the project finance scheme, DFIs can bring a concessional loan, which will help to be more competitive and affordable for the first projects. And last but not least, and it's almost as important as having financial leverages to make the first projects happen and somehow to reduce the cost. We need to have a smooth coordination with local institutions, ministries, local governments. When we work on innovative projects, it can be extremely difficult to understand who does what at the ministry or local government, how green hydrogen projects can be compatible with the existing regulatory framework. We often talk about hydrogen roadmap, about the new law to come to support green hydrogen, but it takes time to implement a new regulatory framework. So it's important, meantime, to understand how the current regulation is welcoming innovative projects. And that can help to save 1 or 2 years of development and have a better visibility and hence to reduce cost also. So that's it for my view, and thank you very much.
Thank you, Matthew. This was very interesting because the emphasis that you laid on enabling these projects focused on the kinds of innovative financing mechanisms that the government and or the multilateral development institutions provide. Can I ask you, supposing you had to look at the specific leverage which the MDBs or the IFIs provide, what is the leverage that is most important for a project to happen? So if you were going to them, and what would you ask them for?
Alors, I see, I will be short in my answer, but I see 2 phases in the project. First, the development phases, and then the stage where we really structure the finance. During the development, we need to work hand by hand with DFIs and local institutions and to have clear and firm support from DFIs toward the local institutions to make clear that green hydrogen projects is bankable and that the DFIs will be ready to finance. It seems obvious, say that way, but believe me, on the ground, it's not that obvious. When you meet utilities, state-owned enterprise and ministries, there could be some skepticism toward green hydrogen. And to make the talk more powerful, if the DFI brings technical assistance, whatever the amount, the topic there is not about the money, but about the positive perception on green hydrogen, that is very positive. So work hand by hand with DFI, with local institutions, local government or ministries is key. And then it's very basic. When we look at structuring the finance of the projects, there are 2 key factors, the equity, the debt. If we can have grants on the equity, that will be a massive leverage on the cost of hydrogen and or cost of electricity if we usually use it as a storage component. And then concessional loan, I believe that mobilizing concessional loan is easier than asking for grants for the capex. But that would be the 2 leverages.
Thank you very much, Matthew. What you have asked is not easy, but at least it's very clear what will make green hydrogen fly. We have a question from a panelist, and I'll read this out. Could any panelists share insights on power purchase agreement with the help of using Green Energy Open Access Rules 2022? And then he goes on to add, we can source the renewable power from the grid to support electrolyzer. I am unable to fully understand the question, but maybe somebody else can be better than I am. Mridula, do you think you could provide?
Sir, I couldn't understand the question, the second part especially.
Could any of the panelists share insights on the power purchase agreement with the help of using Green Energy Open Access Rules 2022? Just let's keep it at that.
I'm not sure, sir. I'm not updated on that. Maybe Matthew, you work in different countries, and also you have your own developer business. Would you like to share some lights on that? I've seen you talking about it many times.
Thank you, Mridula. I'm not sure I understand fully the question either, but I see two way of understanding. On one hand is sourcing green electricity from the grid. For example, in many countries, there are discussions that sometimes they have excess of renewable power, and that they are supposed to sell to the grid, and people are asking if we can use it to make green hydrogen. Technically, yes, everything is possible. Commercially, I don't know how we can secure such green electricity, because today there is an excess. 5-10 years from now, not sure. And I don't think that the APP will want to sell the green electricity at a discounted price forever. And then we can make a dedicated PPA for a company who would like to source green electricity to make green hydrogen. That is very simple to implement.
Thank you. I think this was more in context with the green energy access rules that were put in place by India, which said that you can bank it for use later in the day, etc., as long as it is used within a particular time frame and things like that. So I'm not very sure if that is the
One other aspect is also, I think the 2022 rules also lowers the entry point from 1 megawatt to about 100 kilowatt.
right.
So it allows smaller consumers to now be able to access green electricity purchase, and banking is the other thing. So those are the two things that come to mind.
Yeah.
Yeah, so
To 100 kilowatt, yeah. But I think now they are pushing for 30 kilowatt, yeah.
so
Yeah.
linking with the second part of the question, where he's asking that can be used in the electrolyzer for generation of the green hydrogen. So without knowing the entire policy, but the answering to his question, yes, it's possible. If someone wants to buy a green power anywhere in the country today, he can buy it. Only thing is he has to tie up with those generator of the renewable power who can generate the power and then can supply it.
Yeah.
Generally,
so I think,
that's a long-term
I think that he does say, he says we can source the renewable power from the grid to support the electrolyzer.
Yeah, so
But
someone has to inject that renewable power. So there has to be an agreement between him and the renewable power producers to inject.
or use a trading agency like the
Yeah.
Power Trading Corporation.
So answering to his question, yes, that's possible in Indian context as well.
Just one point, I think the demand aggregation is still not allowed. That was told by me from one of the EV sector industry person. They wanted to have a policy where the demand aggregation can be allowed so that they can meet that threshold 100 kilowatt.
Yeah. It has to be at a single point. So beyond that, if you have to distribute, then the normal electricity regulations come into force, and then you have to have a company, what is association of companies or whatever, to be able to do that. With that, let me end this session. Patil Sahab, maybe you want to say something before we end.
What we all do is what was talked about by Mehta. You actually have a power purchase agreement with the producer, and then you pay a small wheeling charge and take it wherever you want. There are few states which do not allow this. Wherever the grid is, overutilized kind of a thing. But lot many states actually allow. So you can wheel in wherever you want and put your green hydrogen plant somewhere else while the source can be anywhere else.
Okay. Thank you. Thank you so much. With that, I want to thank all the participants and the panelists for this wonderful session. I'm deeply grateful that we are more or less on time.
We have one action item left
Oh.
from this. First of all, thank you everyone, and thank you DG sir and the speakers for a very enriching panel discussion. As a token of appreciation, we would like the session chair to give the souvenirs from ISA's side to the panelist, and then Mr. Ramesh Kumar, Chief of Unit of PPIC ISA, will give it to the session chair. Thank you. So just the action items. So we'll break for tea. This was the second action item, sir. And then after that, we'll reconvene in 15 minutes. Thank you.